Today's lesson is prove the statements about the statements and angles. Segments and angles. Okay, so we're going to look into some statements and also about the angles. So we're going to find out what are the rules, and then what are the postulates, what are the properties that we need to apply to prove some properties about the angles. So important vocabulary that you need to know in this lesson quickly is a proof. So what's a proof? Give me an idea. What is a proof means?
Like to show that you're working correct.
That's right. So it's basically, if you put it in a mathematical terms, in a logical argument, that shows a statement is true. Okay, so that is called a proof. When we're using a logical argument, we're not just saying whatever and then say, yeah, it is true, you need to believe it, but no, we're showing some logic behind why it is true. Okay, so that is called the proof. So in math and in geometry, we use a two-column proof.
Okay.
And you will see this two-column proof a lot entire the geometry. So the two-column proof is like what are the statements we have and why it is true. We're gonna provide the logic behind that. Okay, so we're gonna do some couple of questions that makes more sense to you. So we have this example in the last lesson, but we're using it this one. So whatever is given and then what we have to prove. So for example, if you look at this one, so we need to write a two-column proof. What's given is measure of angle 1 and angle 3, they're the same. What we need to prove is angle EBA, which is EBA. So this angle is same as angle DBC. Okay, so that's what we're going to prove this one by using the two-column proof. So for that one, as it's in the question says two columns, and obviously you're going to draw two columns up here. So the first one you're going to use a statement, and the other column you're going to write a reason. Okay, so you tell a statement and also give you a reason for that. So that's basically as a two-column proof. So let's look into the first statement so you can get some idea. So the first one, you see that is given a measure of angle 1 equals to a measure of angle 3. What's the reason? What can you tell? Mark?
It's because of the same angle.
The reason is here, it is given to you already.
Oh yeah, it tells us.
Yeah, it tells you. Okay, so the reason it's given to you, so that's what it is. Now let's say next one is measure of angle EBA. Let's look into EBA. E is here, B is here, A is here. This I can write a measure of angle 3 plus measure of angle 2. Can you agree with that?
Yeah.
So what is the reason behind it is it's angle addition postulate.
Angle addition.
So angle addition postulates that we learned before. And similarly, you can write a measure of angle EBA. It also can write a measure of angle 2. Instead of 3, we can write a measure of angle 1 because they're equal, right? We can say it's the substitution. Instead of measure of angle 3, we substitute angle 1. So it's called a substitution property. Okay, so now what we can say is from the number 4, next step. So I can write a measure of angle 1 plus angle 2 is same as measure of angle DBC. So if I add 1 and 2, I get the DBC. Okay, same way as angle addition. Angle addition property. So I can see this right here. Again, I'm going to highlight this one. So EBA means is measure of angle 1 plus 2, and then measure of angle 1 plus 2. So obviously I can say these are same, obviously these should be same too.
Yeah.
Okay, so I can write it down here in the last step, number 5, measure of angle EBA is same as measure of angle DBC. So this is called transitive property.
Okay.
So all the properties that we learned before, so we're going to use them to prove any given statement and whatever they need to ask you to prove it. Okay, so this is so famous in geometry, and you will see in a lot of questions in the test also, and you should be familiar with like what property are you applying it. So it's really important that you focus and then learn it right. Okay.
Okay.
Now let's practice it. One of the questions in this one, write 4 steps to proof is given to you. So that means you need to kind of like write the proof for this, like at least 4 steps on this one. The reasons for the last 2 steps. I mean, basically, like you need to give all the steps in this one. So AC, which is from here to here, which is AB plus BC, that is given to you. But what you need to prove is AB and BC are equal. Okay. So you need to prove AB and BC are equal. So how can you prove that AB and BC are equal? I'm going to put some more statements on it right now. First statement is given to you. AC means you can write AB plus BC. Agree?
Okay. Yeah.
So it's already given to you because it's a given. So when it is given, that's where you write it. So it's AC means AB plus AC. That's given to you. So that is called 2-column proof. And you will see a lot these type of questions in coming days. Okay. So the next vocabulary that is really important in this lesson is theorem. Okay. So the theorem is a statement that can be proven. Okay. So that is called a theorem. So that something you can prove. Yes, a theorem. So if we can prove a statement, that is a theorem, we can say. So I'm going to put some theorems up here. So let's go ahead and read carefully so that we can get a good idea. And then we are going to use them in coming lessons or coming questions. Now let's look into the one of the theorems here, congruency of segments. So segment congruency is reflexive, symmetric, and transitive. Let's say if you have 2 segments that are congruent, and we can apply all of these properties up here. So the next theorem is congruency of angles. When 2 angles are congruent, you can apply all the reflexive, symmetric, and then transitive property also. Let's try this question. So they gave you already some statements and some reasons. All you have to find out the missing ones. So AB is 5. So instead of AB, you're writing 5. Instead of BC, you're writing 6.
Yeah.
So what does that mean is you're substituting.
Oh.
Okay. So that's a substitution property. Okay. Then it is yes. You simplified it, and then you can get that. Now let's look into the next question. So here is you need to tell what property is applied for the number 1 and what property applied for the number 2. Look at it, think, and then we can get to there. Yes, first one is transitive because R equals to T and then T equals to P, then R equals to P. Okay, transitive. That's good. Good work. Let's try the next one. Very good. That's it. That is correct. Symmetric property. Yep, very good. So the next one is we're using the properties of equality. So let's use the postulates, the theorems, the properties that we learned. Let's try if we can figure this out. M is a midpoint of the line AB is given to you, and that we need to prove is AB equal 2 times AM. So let's see if we can get something. One. So since we need to write a 2-column proof, let's make it 2 columns. Always in the first column goes a statement, and the other one is a reason why it happens. Okay, so now look at this question carefully. First one, whatever it is given to you, that's what you're going to write first.
Yeah.
Okay? The first one is M is a midpoint of AB. We know that one is given to you. That's easy to write. Second one is, since M is a midpoint, I can definitely say AM is congruent to MB. Do you agree on that?
Yeah.
It's a definition of the midpoint. Do you agree?
Yeah.
So since we know that AM is congruent to MB, so I can write AM equal to MB because they are congruent segments.
Okay.
So the fourth step, I can write AM plus MB, which is AB. Agree?
Yeah.
AM plus MB gives you AB. So this is addition postulate. Okay. Next, let's look into the fifth one. Give me a little bit up. One second. Now the fifth one, I can say, so if AM plus MB is AB, I'm going to write an AM plus, instead of MB, I can write AM. Can you agree with that?
Yeah.
Because MB and the AM are same. What is this substitution?
Okay. Yeah.
Now I see I have 2 of the AMs. So obviously I can add these 2. Like I can write a 2 AMs equal AB.
Is this sublimation supposed to be from this or just this?
Substitution is basically what we did to get this step. That's all it is. Okay? That's why you reason write it. So now here, when I combine these 2, it's a distributive property. Right? So that's a distributive property. And then finally, I can just divide them by 2. I can write AM equals the half of AB. And this is the division property. And that's it. That's what we need to prove, right?
Yep.
That's all. These steps are easy, but the writing that logic, it's really difficult. I mean, we're not doing a really big math and bringing calculations or anything like that in geometry. Geometry is all about logic. If you get that little logics and then writing the reasons good, and you have no problem with this geometries at all. Okay, guys? It's really important. And then you see a lot of questions. I'm not joking around, like almost 2-3 chapters is purely on this writing, because we need to get really good at this. Let's try this.
Given.
Yeah, the first one is given. That's good. It's easy to find. Very good.
Segment? Wait, what is this?
All right. So let's see quickly. Learn today is prove the segments, and angles. We looked into the two-column proof. We already looked into what's the definitions of the proof, two-column proof, and the theorem. Looked into some other theorems, and mostly focused on the two columns proof. Okay. Any questions?
Nope.
Okay. I want you guys. I'll send you this link to this video. Please watch, and then if you have questions, please ask me.